This video is about factoring and the discriminant test as it says up there. So this one's going to hopefully be very short. Basically, if we were trying to factor a trinomial, so something like, let's try an x squared minus 2x minus 15. Okay, we can bang our head against the wall for a while and try this, but we don't know, how do we know for sure if it's factorable or not? One of the ways is, or the way is to look at the discriminant, which is b squared minus 4ac. Remember, that's what's underneath the radical in the quadratic formula. So b in this case is minus 2, and we square it, we're going to get a 4. Minus 4 times a, which is a 1. It's the coefficient of the x squared there. So 4 times 1, and c is going to be this negative 15 times a negative 15. So if we sum those up, we're going to get 4. This is going to give us 4 times 15 is 60, and it's going to be positive because there's two negatives here. So we're going to get minus 4 times minus 15 is plus 60. Plus 4 is 64. And now what we say is 64 a perfect square? And it is, right? Because 8 times 8 equals 64. So we know that this one will be factorable. Okay, and then the most surefire way to factor this one could be done by inspection. Looking at it, we could probably figure out what needs to go in here to get an x squared minus 2x minus 15. You might be able to just say, well, that's an x and an x. The 15 here is going to be a 3 and a 5, so and the difference between 3 and 5 will give me a 2. I need a negative 2 for here, so I'm going to make the larger one, the 5, a negative, this a positive. And then looking at this, we'll get the x times x will give us the x squared. We'll get plus 3x and minus 5x, which is going to be a minus 2x. And we'll get 3 times minus 5, which is a minus 15. Okay, but a more surefire way to do this is to plug a equals 1, b equals minus 2, and c equals minus 15 into the quadratic formula, or into the program in our calculators that has the quadratic formula. And if we do that, we'll see that the solutions are x equals minus 3 and 5. So when x is minus 3 or 5, those will be solutions to this. And then the zeros of the function, we know that the factors then are going to be x minus each of these factors. So x minus minus 3 is an x plus 3, and x minus that 5 is going to give us an x minus 5. And we should end up then with the same thing that we did. Okay, so once again, these are easy. Sometimes your quadratic's easy to look at and factor, but many times, especially if we have some leading coefficients and so forth, this other method will always work of using the quadratic formula. But remember, you want to do the discriminant test first, see if you get a perfect square. And that concludes our factoring of binomials.